Hey guys, happy Monday. So I apologize for not being here again today. I am on campus, just meetings all day. So again, I do apologize. However, we still have to move forward. Midterms are right around the corner. So again, we cannot fall behind. Um, you guys know how this works. We're gonna jump right into it. So what I want you guys to do, pause the video, try your warm up, and then hit play, and we'll go through it together. All right, guys. So for the warm-up, solving a multi-step equation. Remember, essential standard number one. All right, very first thing I see is I see my parentheses right here. I got to distribute, but it's not just a 2 that I distribute. It is going to be a negative 2. Negative 2 times 9, negative 18. Negative 2 times 2c is going to be negative 4c. Drop down the equals 34, and don't forget to drop down at the very beginning here. I had a 3c. All right, well, what's the next thing that I have to do? Combine my like terms. I got 3c's minus 4c's. They're both on the same side. So again, am I going to add them, subtract them? It depends on the signs. 3, and it says minus 4. So 3 minus 4 is negative 1c. Drop down the minus 18 is equal to 34. What do I have to do next? Well, I have to add 18 to both sides. Plus 18 plus 18. Those cancel out. Negative 1c is equal to 8 plus 4, that's 12. Carry the 1, that's 3, 4, 5. That is going to be 52. Last thing I have to do now, guys, is divide by negative 1. So I divide both sides by negative 1, divide by negative 1. I get c is equal to negative 52, guys. So go ahead, check that if you got it right. Good job. If you didn't, go back, guys. Fixed a little mistake. Something you guys want to watch out for. All right, let's move on. Here is the title of today's lesson, Graphing Linear Equations, Day 2. How do I graph a linear equation? We were graphing, and we were actually writing equations of lines, but today we're actually going to jump into y equals mx plus b. And how do I use that? How do I use that y equals mx plus b to help me graph? All right, some of you guys might remember this from last year. So again, how do I graph a linear equation? Today it's all about graphing. If anybody were to walk in, you should be able to teach them by the end of today. So I do want you guys to copy this down. Slope-intercept form. Remember, that is y equals mx plus b. Now we needed two important key pieces of information. I needed my slope, which is what I use is my m, and I needed my y-intercept. So where does the line cross the y-axis? And that was considered my b. Okay. So how do I go about graphing it? Well, all depends on those two key pieces. Well, you always, when you want to graph using y equals mx plus b, you want to make sure that you start, okay, at the beginning right here. Think of b as your beginning. You always want to start with your y-intercept. So if you see in this example here, they went ahead and they went on the y-axis. Don't forget, y-axis runs up and down. They went down to -1, and that's where we see their very, very first point that they placed there. Okay. After that, they have to move according to their slope. Now, their slope, again, that is considered your m here. Their slope is 1 over 4. That's the changes in the y's over the changes in the x's. So again, y means up and down. So from that point, because this is a positive one, would I go up? Would I go down? Because it's positive, I'm going to have to climb up 1. Okay. Now, the change in the x is left and right. Because it's a positive 4, I have to go right. If it was negative, I'd have to go left. So again, positive 4, I climb over 1, 2, 3, 4. And that's where I would put my second point. Remember, I only need minimum of 2 points for my line. So I'd go ahead and I would, let me take a different color here, purple. I would go ahead and draw my line connecting those points, and I've created my line. All right, guys. So let's jump into one here together. So it says write each equation in slope-intercept form and then graph it. All right. Well, again, set up your coordinate plane. Make sure you guys copy that down. Where do I want to start off? I always begin with my b. What is my b in this case? 4. That's where I need to start. That is going to be my y-intercept. So I want to start on the y-axis going up or down. It's a positive 4, so I better go up 1, 2, 3, 4. And that's where I place my first point. Okay, what I want to do next is, well, I need a minimum of 2 points for my line. I'm going to have to go ahead and use my slope now. Now, the awkward thing is, hey, my slope is, your rise over your run, that change in y over change in x, but I have it just a nice whole number there. Well, Let's make this a fraction by putting it over 1. So I know my delta y's is the change in the y's is positive 2, the change in the x is positive 1. So from that point, okay, that y-intercept, what I need to do from right there, the changes in the y's, I have to go up 2, so up 1, up 2, and I have to go across 1 to the right. And why do I go to the right? Because that is a positive. If it had been negative, I would have gone left. Okay, and actually I can keep this pattern going up 1, 2, over 1. Okay, up 1, 2, over 1. Just to get a much straighter line. Now, some of you guys kind of caught on to the pattern. If I go up 2 and right 1, is that the same thing as going down 2 and left 1? Yeah, absolutely. You can actually do the reverse of both. Just be careful with that, right? Down 2, left 1. Notice I start getting my line. Let me go ahead and connect those as straight as possible, and there we have it. That is how we graph a line in slope-intercept form in y equals mx plus b form. All right, guys, example 1. I want you guys to go ahead and try that. Okay, so copy y equals negative 2x minus 3. Pause it right here. Resume when you're ready to go through it. Okay, so this is what you guys should have done. You want to start off with the y-intercept. That is negative 3. Okay, so that means I'm going to go down on the y-axis down 1, 2, 3, negative 3. There we go. We have our very first point. Now you have to watch out with this one. What is our slope? I need another point. I'm going to use my slope here. This is negative 2 over 1. Okay, changes in the y's over the changes in the x. Delta y over delta x. Because the change in the y is negative 2. Does that mean I'm going to go up 2? No. I have to drop down now 2. Now, ask yourself again. The changes in the x, that's left and right. Because this is a, what kind of one? Positive one. I have to go right one. And there we have it. I have my nice 2 points. That's enough for a line. Again, you can add more points if you'd like, just to get a much straighter line. So there we have it. That is the expectation, guys, by the end of today. Graphing it in slope-intercept form. All right, example 2. Let's go through this. Okay, so we'll do this one together right here. So again, take a second, pause it, and we'll go through it. So we have y equals negative 2 over 5x plus 3. Now, this is the one that tends to confuse people. Okay, I'm gonna start graphing like I normally do, right? Let's start off with our y-intercept. Our b value is 3, so I'm on the y-axis one more time. We always start on the y. I'm going to climb up 1, 2, 3. That is my y-intercept, positive 3, which is given by the b. This negative right here tends to confuse people. So this is what I always do. Naturally, for me, I like to take the negative and I just throw it up top. I say this is negative 2 over a positive 5. Now again, let's see what happens here. Delta y over delta x. Well, if I use this slope now, the y's are changing by minus 2. So on my y-axis, I can't go up because this is a minus 2. I'd have to go down 2 and across to the right because this is a positive 5. 1, 2, 3, 4, 5. Okay, and I'm going to go ahead and I would draw my line. Now, here's another way you could have done it. What if that negative, if I applied it to the bottom? So what if I said instead of saying negative 2, I said positive 2 over a negative 5. Huh. Well, I still plotted at 3, right? It still would have gone at 3 here. But this is now telling me that I have to go up 2. So you're telling me I have to go up 1, 2. But then on the x-axis, the changes in the x, I'd have to go not right, but actually left 5 left. 1, 2, 3, 4, 5. Does that still give me the same line? Yeah, you actually see those 3 points are perfectly lined up for me. Okay, so it's up to you. Naturally, we just kind of apply the negative to the top one, but either one works. However, can I say that this is a negative 2 over a negative 5? No. Don't do that, because what's a negative divided by negative? That'd be saying that this is a positive 2 over 5. Okay, that's not what this slope here is saying. So watch out with that. You cannot make both of them. Watch out with that. Okay, let's go to example 3. Okay, this is the challenging one right here, guys. All right, you ready? So it says, write the equation in slope-intercept form. I have been so nice that I've been saying, hey, everything has been in y equals mx plus b form. Okay, this is actually not in that form. I have 4x plus 2y is equal to 8. This is actually what we call standard form. How the heck can I write this so it looks like y equals mx plus b? Well, if you notice for a slope-intercept form, the variable that's all by itself is the y. So my job right here is to get this guy all by itself. Well, I don't want to move the 2 just yet. I actually want to get rid of a positive 4x. Again, my whole goal is to get it to look like this. Let me get my y all by itself. How would you guys get rid of a positive 4x? Well, you'd have to do minus 4x. Whatever I do to one side of the equal sign, I have to do to the other. Now, most students are familiar with this, right? What happens with the 4x minus 4x? They cancel out. I got this. Bring down your 2y is equal to, and this is where the mistake happens. Can I subtract a minus 4x from an 8? No, because this here doesn't have a variable, and this does. These are not like terms. But notice the way I'm going to write it. I'm going to write negative 4x. What kind of 8 was that? That was a positive 8, so I'm going to say plus 8. Notice how I'm almost getting that mx plus my b. I'm almost looking like that mx plus b. My only last issue that I have here is I have to get rid of that 2 out in front. Ask yourself, what's going on between the 2 and the y while you're multiplying? So how do I get rid of multiplication? The inverse operation says I have to divide. Okay? I have to divide, but what am I going to divide? Then as soon as do I divide the 4? Do I divide the 8? Well, you have to actually divide everything by 2. Okay, this is the awkward part. Well, the 2 divided by 2 is just 1y, so we get y is equal to, what is a negative 4 divided by 2? That's going to be a negative 2. Don't forget your x. What's an 8 divided by 2? That's going to be a positive 4. Hey, we got it. This is slope-intercept form. Y equals negative 2x plus 4. Let's go ahead and graph this, guys. All right, I'm going to start. Let me use red here so it pops up. Start off with our y-intercept. My y-axis, I'm going to go, that's a positive 4, so let me go up 1, 2, 3, 4. Okay. What is my slope? How do I get the second point? It's all right here. It's all in the m. This is negative 2 over 1. Now watch out with that, right? Negative 2, that's a change in the y's over the change in the x. The negative 2, does that tell me to go up 2 or down 2? That's going to be a down 2 because it is a negative. So let me climb down 1. Let me climb down 2. I'm not done yet. My slope also says the change in the x. It's a positive 1, so I have to go to the right one. There we have it. So again, I can keep this pattern going. Down 2 over 1, down 2 over 1. Don't forget, a line is composed of an infinite amount of points. This goes on forever, forever, forever. This line has a ton of points. All right, guys, there we have it. So that is the expectation for today. Can you graph things that look like y equals mx plus b? And if they're not, can you guys change it? Again, think of inverse operations, right? Let's jump into today's class activity. Okay, here you guys have it. You have 1, 2, 3, 4, 5. Notice these first 5 problems. Oops, not even 5, right? How wasn't that nice? These guys right here are already in slope-intercept form. They're already in your y equals mx plus b form. They're good to go. You can graph them. Watch out with that one. That's actually a negative 1 chilling right in front right there. So if you want to throw a negative 1 in there, go for it. That might help you out. Now again, this negative, just like the problem we did, does that negative apply to both of them? No, just pick one. It's either negative 1 or negative 2. It's completely up to you. Okay, now these last 2 problems, 19 and 20, they are again standard form. I have to go through and fix it. So watch out. Take a look at the last example that we did. All right, guys, the expectation, you guys know what it is. Get these 6 problems done. Okay, once you're done, turn them into the inbox, please. All right, whatever you don't finish does become your homework. All right, guys, have a great day. I will see you guys all tomorrow.